Up to now, we have described evaluation metrics that apply exclusively to categorical data. Specifically, for binary outcomes, we have described how sensitivity, specificity, accuracy, and F1 can be used as quantification of how well the algorithm is working. However, these metrics are not useful for continuous outcome. In this video, we described how the general approach to defining best in machine learning is to define a loss function, which can be applied to both categorical and continuous data. The most common used loss function is the squared loss function. If y hat is our prediction and y is the observed outcome, the squared loss function is simply the difference squared. Because we often have test set with many observations, say n observations, we use the mean squared error, which can be defined like this. In practice, we often report the root mean squared error, the RMSE, which is the square root of the MSE, because it is in the same units as the outcomes. But doing the math is often easier with the MSE and is therefore more commonly used in textbooks, since these usually describe theoretical properties of the algorithms. Note that if the outcomes are binary, both RMSE and MSE are equivalent to 1 minus accuracy, since y hat minus y squared is 0 if the prediction was correct and 1 otherwise. In general, our goal is to build an algorithm that minimizes the loss so it is as close to 0 as possible. Because our data is usually a random sample, we can think of the MSE as a random variable, and the observed MSE can be thought of as an estimate of the expected MSE, which in mathematical notation we can write like this. Note that this is a theoretical concept because in practice we only have one data set to work with. But in theory, we can think of having a very large number of random samples, call it B, apply our algorithm to each, obtain an MSE for each random sample, and then think of the expected MSE as the average, or this equation. Here, YIB denotes the ith observation of the bth random sample, and y hat IB is the resulting prediction obtained from applying the exact same algorithm to the bth random sample. Again, in practice, we only observe one random sample, so the expected MSE is only theoretical. However, in a later video, we describe an approach called cross-validation that is used to estimate the MSE by trying to mimic the theoretical quantity. Note that there are other functions other than the squared loss. For example, the mean absolute error uses absolute values instead of squaring the errors. However, in this course, we focus on minimizing square loss since it is the most widely used.